Welcome to the deep dive. So, if you've ever worked in professional audio or broadcast, you know the Achilles heel of any long run is, well, it's copper cable.
Oh, absolutely. It's heavy, it's expensive, and it gets noisy.
Exactly. So, today we're diving into the Thor Broadcast F-16A-TxRx kit, which basically promises to swap out, hundreds of pounds of copper for a single strand of glass fiber.
And our mission here is to figure out how this kit doesn't just improve on copper, but really changes the entire game of signal transport.
The immediate hook, and you should really pay attention to this, is the density.
Right. 16 channels of unbalanced unidirectional analog audio. We're talking the full range, 20 hertz to 20 kilohertz, all just zipping across one optical fiber. It's like the ultimate shortcut to getting smart on modern audio infrastructure.
Okay, let's unpack that. The core mechanism here. It's not just sending an electrical signal down a different kind of wire, is it?
No, no. It's a full conversion. You've got the transmitter, the TX unit, takes that analog waveform, and it basically turns it into a modulated digital stream of light.
And light doesn't care about electromagnetic interference.
Not at all. No hum, no buzz, no signal drop-off. Then the receiver, the RX, it just takes that pure, pristine optical signal and turns it right back into its original analog form.
And what's really fascinating here is the speed.
Yeah.
They advertise extremely low latency, just 1 millisecond.
That 1 millisecond is critical. I mean, it's everything. It means this is perfect for live events, concerts, auditoriums. Anywhere, timing is non-negotiable.
Because any more than that, and you'd get a noticeable delay, like an echo.
You'd hear it immediately. This keeps the delivery completely seamless.
Okay, beyond the physics, let's talk connectivity. This model, the F-16A, it gives you 16 channels using terminal block connectors. For anyone who isn't an installer, why does that matter?
Terminal blocks mean this is really designed for permanent infrastructure. It's going into a wall or a rack, not a touring case you throw in a truck every night.
Got it. And the spec sheet mentions a 600-ohm unbalanced impedance. Now that's interesting.
It is, yeah.
Because usually pro systems use balance lines specifically to reject noise. So if this is unbalanced, how does it avoid all that noise that unbalanced copper is famous for picking up?
It's actually pretty simple. The noise rejection happens because the signal immediately becomes light. It travels, a few inches on copper inside the box before it's digitized and made immune.
So you solve the noise problem before it even leaves the rack.
Before it has a chance to start. And if 16 channels isn't what you need, they do mention that models with 2, 4, 8, and even up to 32 channels are available, so you can scale it to your venue.
That scalability is a huge deal. But I think the real paradigm shift here is the distance. With copper, you're thinking in feet, here.
Here you're thinking in kilometers. The base unit supports up to 20 kilometers right out of the box on standard single-mode fiber.
20 kilometers, that's just staggering.
And that's just the start. This is where it gets really interesting. They mention specialized models for long-haul signal transport up to 120 kilometers.
120 kilometers, that's not just a long distance. That completely changes how you'd even scout locations for a big event. The savings on logistics and costs must be enormous.
Oh, absolutely.
Yeah.
You're eliminating all that heavy, bulky copper, all the booster amps you'd need. It's a different world.
So while we're celebrating this, I have to ask, it's a single strand of fiber carrying 16 critical audio lines. Is the physical risk, that single point of failure, a big trade-off?
It is a serious consideration for sure. You protect that cable. But the trade-off is almost always worth it because the audio quality you maintain is just broadcast grade.
What are we talking spec-wise?
The digital conversion is happening at a 48 kilohertz sample rate, 24-bit bandwidth. That gives you a signal-to-noise ratio better than 79 decibels.
Which is better than CD quality.
Way better.
Yeah.
And you're preserving that quality over 120 kilometers.
Yeah.
You can't do that with copper. It's impossible.
So to wrap this all up, what this really means for you is that this technology offers incredibly dense, noise-immune, broadcast-quality audio transmission across distances that used to be unthinkable.
Right. It solves the physical limitations of audio transport. But yeah, here's a final question for you to mull over. We've focused on this unidirectional kit, the F-16A-TxRx.
Sending signals one way.
Exactly.
Right.
But the source material also mentions a bidirectional kit, the F-16A-BTxRx. So if sending 16 channels one way is this efficient, what are the implications for a complex live show, like a concert or a big sporting event, when you can send 16 channels both ways simultaneously over that same single strand of fiber?
Wow.
Think about the instant feedback loops, the intercom systems, the command structures that suddenly become possible.